So question 29. Kenny is going bowling. The cost per game is $3. So usually when it says cost per game or cost per, this is the indication where it's the slope, okay? Or so in Desmos I would say $3 and then times X, because it's per game. So we're trying to figure out what is the maximum number of games, okay? All right, so it says here, he will also need to rent a pair of shoes for $1.75. He can spend up to $20. Okay, so which means that, so he's going to pay $3 per game, plus he also has to pay $1.75 to rent a pair of shoes. And then he has $20 to spend. So all together, he only has $20 to spend. So I directly went ahead and just put this in Desmos, because then I can see it's about 6 games. He can play about 6 games. So if I were to say like 3 times 6 games plus $1.75, that's about $20. If he plays, the only other option higher than that is 9. That would be way too much. He won't have enough money. If he pays 5, he has enough, but it says here maximum amount of games. So we want to know the most games he can play. So around 6 games. Okay, so yeah. Usually on the word problems, if you have just one variable, then it'll look like this. You'll have the slope times X, and then you have some sort of flat fee here. All right, another word problem. It says here, Malik can spend no more than $24 to buy pecans and cashews. He will pay $6 per pound for pecans and $8 per pound for cashews. Which graph best represents the number of pounds for pecans and the number of cashews Malik can buy? All right, so for this one, you have here X and you have a Y. It looks like X is for pecans, and then for Y you have cashews. So if he can spend no more than $24, so let me go ahead and see $6 here times, for pecans it's X. I'll just put 6X here, plus you have $8 per pound for cashews. I'm going to put Y because it's on the Y here. And then whatever he spends, it has to be less than or equal to $24. He cannot spend more than that. So I have a graph here. So it can be between these two, so 3 and 4. So 3 and 4, it gets shaded below because he had this. Anywhere here is what he can spend, or the number of pecans and cashews, and then it's a solid line to this one. All right, next one. Point A is an element of direct variation. What are 2 points other than A that are elements of a direct variation? Okay, so that would be our vocabulary word. So remember, for direct variation, we needed to go straight through 0, 0, and it has to be a straight line. So here, if A is part of the direct variation, another point you can pick is 0, 0, because it has to be that. Okay, this is not the only option, but I would say the easiest option right here, that point. And it has to have the same slope. So if you look here, you have 1, 2, 3, 4 over 1. So I picked that point. And then the other point is 1, 2, 3, 4 over 1. I picked the other point. The other point is at 1, 4. So I'm just going to put 1, 4. You can also pick, you can keep going up. 1, 2, 3, 4 over 1. So you can pick 2, 8. Or if you can come down here and left, and then 1, 2, 3, 4. You can pick -2 and -8. Those would be all of the points that you can put in here. Do not put this point, because negative 1, 4, because it says what are 2 points other than A, so A wouldn't work. Okay? Just the way they're asking that question, honestly. All right, what graph has exactly one x-intercept and one y-intercept? So you need a point going through the x-intercept, x-axis, and you need one point going through the y. This one has no x-intercept, only one y-intercept. This one has one x-intercept, no y-intercept. So obviously this one, because it has one x-intercept right there and one y-intercept right there. This one, yeah, doesn't work either. Which equation best represents the data? Okay, so we're going to go ahead and plug this data in here. I could put in all the points, but obviously I'm going to use it as a table, much easier to enter, and then you can also use this for your regression. So type them all in, and if I press enter, it just predicts the next one. That's a nice and quicker way to do it. Typing them in. I hope you can see the pattern that it's graphing. Looks like a quadratic because it's definitely curving right there. 0 and then one more, 0.3. Okay, so I do have a shape of a quadratic here. It has a curve. So I would say either this one or this one because of the x squared. Let's see, I'm just going to graph them and see which one. I would say that one looks good. If I want to go ahead and try the next quadratic, I mean, if you want to try all of them, you can. You're going to pick the one that's closest. Yeah, see, that one's not even close. So it would be that one. That's about it for that one. Oh, 34. Yep. All right. The relationship x and y is shown in the table. Which equation best represents? So same thing here, same process. I'll go ahead and plug in the table. Five and 10. All right. And this also kind of has like a curve to it, so I would say quadratic. So either the first one or the third one. But again, if you want to just graph all of them, that's totally fine too. These are the easy questions, I would say. That one looks okay. I'm going to skip down to the third one just because I can see that pattern. It definitely looks like a quadratic. And that's a very good fit right there. I'm going to pick this one. But, you know, remember, you're trying to get as many questions correct as possible. So it's maybe a good idea to check all of them and just make sure you got this one correct. Yeah, it's definitely that one. That one. There you go. That one's the one that matches my points. All right. Miss Scott will pay $2,000 to have her house painted. The amount each painter earns, A, varies inversely, so that's my vocabulary word right there, for the number of painters N that will paint the house. Which equation best represent? So because it says varies inversely, I can go ahead and look for a graph that basically has the shape of like something like this shape right here. Okay, not a straight line. A direct variation has a straight line. But for this one, I'm going to go ahead and just look for that inverse looking graph. So now here, if I put A times N, it's not going to do anything for me. So I'm going to just change A to Y, lowercase y, times N or X, and see what I get. Well, that's definitely inverse. I would say this one, but you know, I want to go ahead and check the rest of them. So 2,000 equals y plus x. I'm just changing them so that I can graph it. That's definitely not that. For this one, y equals 2,000 and x. That doesn't look like it. I don't even know why I'm even doing this. I know the answer for sure is the first one. But, you know, like I said, we want to make sure. Yeah, that one's not it either. Definitely this. All right. The following graph has a relation, shows a relation. What is the range? So the range is the y-axis. So it looks like on the y-axis, it's at -4 right there, and it's going up. So it's all real numbers greater than or equal to -4. If this said domain, then it would be all real numbers because it's going to the left and it's going to the right. But since it's saying range, I'm going to say all real numbers greater than or equal to -4. Which of the two functions has exactly two different zeros? So I would highlight the word zeros as my vocabulary word, and zeros just means x-intercepts. I think of them as x-intercepts because that's where your function is equal to 0. Anyway, when I'm reading this question, I'm reading it as which of these functions has exactly two different x-intercepts. Okay, so we're just going to graph them all in. Well, okay, well that one works. This one has exactly two x-intercepts, but you know, this is a very easy question to do because of Desmos. So I'm gonna go ahead and check all of them just to make sure. Yep, this one only has one x-intercept. That's not gonna work. That one also has only one x-intercept right there, right? And then this one will also have one x-intercept. So it's going to be the first one, but I'll follow through on what I said. Try all of them, okay? 3x minus 10 over 3. Yep, this one also has only one x-intercept. All right. Which equation could represent the graph that has x-intercept at 4, 0 and -7, 0. So we're just looking for those particular x-intercepts, okay? So again, graph them. Desmos does a great job of graphing them. So -7, oh, close enough, but not, oh, maybe it is that one. I typed it in wrong. Hold on. -7 and +4, -7 and +4. Man, I'm getting lucky with having them all be the first one. But you're not. You might not be that lucky because you have to kind of switch them around. Or yours are going to be mixed together. Randomized, that's the word. All right, anyway, what number is a zero of a function? So zero of a function just means x-intercept. Let's just think about it. It is look at x-intercept. So x squared plus 3x minus 18. So this one has a 0 at -6 and +3. They just want you to pick one of them, and the one that they picked was -6. It doesn't have +3 in here, so that looks good, even though +3 is also a 0 of this function. All right, for this video, I think this will be the last one I'll do, and then I'll start the next one. Which of the following graphs appears to be a function? So a function is where you do not have any x values repeating. So basically it doesn't go sideways like this. Okay, so this is not a function. C is not a function. B is a function because you see how all of the x values only have one output, and D is also. The answer is B here. All right? Let's start the next video.